In this set of videos, we'll be learning how to evaluate the powers of tangents and secants, and as well as cotangents. That's cotangents and cosecants. So take note that tangents and secants always go together, and cotangents and cosecants, they always go together. So in this type of integrals, we will be looking at the angles. So the angles of both tangents and secants, and as well as cotangents and cosecants, must be the same, while their exponents may or may not be the same. So in evaluating these type of integrals, we need to be reminded of the Pythagorean identity. So there are two Pythagorean identities that we need to be using here. So the two Pythagorean identities are tangent squared u plus 1 equals secant squared u, and cotangent squared u plus 1 equals cosecant squared u. So if you will have trouble memorizing these two identities, now you can just remember or try to recall the Pythagorean identity for sine and cosine. So that's sine squared u plus cosine squared u equals 1, because these two are just derived from this identity. So if you are going to divide this identity by sine squared u, the entire equation here by sine squared u, will be able to get this identity. And if we're going to divide the entire thing by cosine squared u, then we'll be able to get the first identity here. So there are a total of four cases here for the powers of tangents and secants. So let's go to the first case. So case number 1 is if the exponent of secant u or cosecant u is 2. So regardless of the exponent of tangent and cotangent, if the exponent of secant u and cosecant u is equal to 2, then we can perform directly integration by simple substitution. So wherein in substitution, the new variable must be replacing tangent u so that the differential is secant squared u du. Or if the function is cotangent of u, then the differential is cosecant squared u du. But remember, it's negative. So for example, we want to evaluate the integral of tangent squared x secant squared x dx. So regardless of the exponent of tangent x, because we have secant squared x, then we directly use substitution by letting u equals tangent x. So don't include the exponent, just like what you did with the powers of sines and cosines, wherein one of the factors, like it's either sine or cosine, has an exponent equal to 1, so substitution. So du here is secant squared x dx. So therefore, this is equal to the integral of u squared, and then this part here, secant squared x dx, is already our du. So that's du. So the integral is u cubed over 3. Don't forget the plus c, where that's tangent cube of x over 3 plus c. Okay, another example for we want to evaluate the integral of, let's say, square root of cotangent of 3x dx over sine squared of 3x. So in this example, we don't see a cosecant, no, that's raised to the power of 2. However, we have here sine squared 3x in the denominator. And we know that the reciprocal of sine squared is cosecant squared. So this in this example, we're just like writing the square root of cotangent 3x and then cosecant squared 3x dx. So we already have cosecant squared. So remember, as long as the exponent of secant or cosecant is 2, then we can perform substitution. So here we let u equals cotangent of 3x, so that du equals negative 3 cotangent, or cosecant squared rather, cosecant squared of 3x dx. So substituting, so this is now u raised to the power of 1/2, and our cosecant squared 3x dx is negative du over 3. So remember, don't forget to put a multiplication sign to indicate that you're multiplying here, because if you don't put this here, it's just like you're subtracting du over 3, which changes the operation. So we now have negative 1/3 integral of u to the power of 1/2 du. So that's negative 1/3. So u to the power of 3/2 over 3/2 plus c. So our answer is negative 2 over 9. And then our u is cotangent 3x. So we can just put that inside a parenthesis. So cotangent 3x raised to the power of 3/2 plus c. But if you want to express it as a radical, then you can always express that as a radical. So that would be, in terms of radical, that would be negative 2 over 9, and then cotangent 3x square root of cotangent 3x plus c.